All right, so on this problem, we need to rewrite this so it looks like this. So something that we talked about in class a few times is when you have a function in a radical form that looks like this, the rth root of b to the n, that we can rewrite that with a rational root and put whatever the exponent of the b inside is in the numerator and the root underneath. And we can rewrite it with a rational exponent. And just to remind you, rational means that the exponent is a fraction. That's what rational numbers are fractions. So we have to take this and rewrite this. Now, just so you know, when there's no number for an exponent, it's a 1. And when there's no root in the number, it's a 2. So we need to rewrite this as log base b of 2 to the 1/2 power. And I got to get my stuff back over here for a slow hold. Okay, so one of my properties is I can take an exponent and move it to the front, so I need to move a 1/2 to the front. And that will be log base b of 2. And since log base b of 2 is this part right here, it matches exactly with that, this is going to be 1/2 of 0.3562, which means you can take on your calculator 0.3562 and divide it by 2, and then that will be your decimal answer right there. Okay, so let's see, we got, oh, somebody said that that's the wrong page, so we're going to go do the same thing on page 233. We're going to do number 36 on page 233 as well. So this one is page 233. And let's see, we got 8 times the number of 3 raised to the 6 minus x power equals 40. So this problem, whenever you have an exponent that has a variable in it, we have to get everything away from that part to the exponent. So the thing that's there with that is this 8. We got to get rid of this 8. And since 8's by the parenthesis, that means it's multiplying. So I got to divide by 8 on both sides. So these reduce, and that leaves me 3 to the 6 minus x power equals 5. So now I've gotten this variable part with the base all by itself. And I got a couple options here. I could do base stays base, the other two place switcheroo, which probably would be faster, or I could natural log both sides. So either way you could want to do this. Matter of fact, I think I'll show you both ways. So what I can do is I can log both sides or natural log both sides. And the reason I want to do that is whenever I have a variable that's in an exponent, the only way to get a variable out of the exponent, oh, that's number 30. Okay, it's still the same thing. All right, I'm going to do 36. So I started to do 36, I think, yeah. 6 minus, this would be a 2x here. And let's see. All right, I got to do this whole thing again. So let me erase this. Sorry, that was 30, but the steps are the same, but we'll do 36 because that's the one you want to see. So we got 8 times 4 raised to the 6 minus 2x power plus 13 equals 41. So again, we want to get the part that has the variable to the power all by itself. So this part right here, we need to get this part all by itself. So you're kind of thinking about that whole part as being the variable x that you want to get alone. Like it says 8x plus 13 equals 41. So you got to get rid of the plus 13 first by subtracting 13 from both sides, and those go away. And let's see, we got 41 minus 13 is 8, 28, and then over here we got 8, 4 to the 6 minus 2x power. So we also need to get rid of this 8. So we have to divide both sides by 8, and we get this. So we got 4 raised to the 6 minus 2x power equals 28/8. Now there's again 2 ways to go from here. So I got to get a variable out of the power. So again, you can log just regular log side or ln. So I'm going to ln this side and ln this side. And now I get to move this power to the front. And that gets the variable out of the exponent. And now I'm going to do algebra 1 stuff to get this x all by itself. So what I would do is I would divide each side by natural log of 4. And then these reduce to 1s. Then I've got this 6 minus 2x equals the natural log. And if you want, you can reduce that fraction and whatever, but we're going to end up doing it on a calculator anyway, so I'm just going to leave it the same. If you want to reduce it, you can. Now I got to get rid of this 6 because I'm trying to get this x all by itself, so I'm going to subtract 6 here, and over here I'm going to write it to the side because it's not a like term to this, but these two are like terms. They cancel out. So that gives me negative 2x equals the natural log of 28/8. There's a minus 6 out here, and that's over the natural log of 4. And then last, I'm going to divide both sides by negative 1/2, or I could multiply by negative 1/2. That's the same as dividing. So over here, I'm going to multiply both these sides by negative 1/2. I'm going to do the same on both sides. So the negatives cancel and the 2's reduce. And that gives me my x. And then I would probably write it like this. So I'm going to type this in my calculator, just like this shows. Just exactly like this is on my calculator. So I would recommend you do that as well. So I'm going to take my calculator and put it up there and show you how that works. I hope this is working because I cannot see this thing. Can you guys see my calculator? Somebody tell, or not my calculator, but the screen. Can you see the screen? Okay, let me put a calculator over there and see if you can see it. I hope so. Hey, can you guys see this calculator screen now or not? Yes, okay, great. I'm glad you can. All right, so what I'm going to do is, can you see the regular screen as well? Oh, awesome. I don't know what's happening, but I can't see my calculator on the screen. So I'm going to turn this on, and I'm going to quit that screen. I'm going to clear that all off, and now I'm going to type in what you can see on the white screen. So I would have alpha y equals 1. And I'm going to put in a negative. Don't put the minus sign. You need a negative. Negative 1/2. And I'm going to do a parenthesis. Wrong parenthesis. And then I'm going to do alpha y equals again to view a fraction bar. Oops. And I got the natural log of 28 divided by 8 on the top, and on the bottom I got the natural log of 4, and you got to end those parentheses, and I got a minus 6 out there all by itself. Hit enter, and there's our answer, 2.548. So that would be the answer to this problem, 2.548. Does anybody else have anything you want me to go over? Just to let me know, can you guys still see the calculator on your screen? Is it still up there? Because I can't see it on my screen. It is, okay. Anybody else got anything you want me to go over? anything from unit 3.1 through 3.4, because that's what your test is over tomorrow. And you gotta come to Zoom tomorrow because I'm giving you the access code on Zoom. Anybody got anything? Last go around, I'm gonna go back up on the chat, see if anybody else has asked any other questions. All right. Well, if you guys are done, I'm done. Last go around. Anybody else got anything else you want? Okay, we are going to meet tomorrow at Zoom, same time, same place. And then that'll be the last chance you have to ask questions. You need to email me, just to remind you, you need to email me the trail walk. You need to email me page 233, take pictures and email them to me. And if you want the bonus homework points, you have to email me pictures of the worksheet or the bonus sheet worked out on paper front and back too. So if you're done, I'm done, and I will see you all tomorrow morning, bright and early. I hope you have a great day. And if you get questions during the day, now I may not be able to answer you right away because I'm going to be Zooming every period. So I will get back to you as quickly as I can. If you have questions, please make sure you ask. And I hope you have a good day, and we're going to have to do the best out of this. We're going to probably, this Zoom thing is not ideal for any of us, including me. But I do want you to know that we're going to do the best to make it the best we can for you. And the more questions you guys ask, the better. Some of you that aren't asking questions that I think should be, if you notice, I got some people asking me questions that you didn't see because they privately chatted with me. You are more than welcome to privately chat with me here and get your questions answered too. You don't need to be shy. So I'll see you guys tomorrow at the same time. I hope you have a great day. Bye.